In this example, we have a continuous random variable x with a probability density function given by f of x equals a half e to the negative absolute value x. If y is equal to x squared, we need to find the cumulative density function for y. Okay, so if y is equal to x squared, this tells us then that y is between 0 and infinity. Y is non-negative. So that's the first piece. The cumulative density function is going to look like the probability that our random variable y is less than or equal to some value little y. So this is the probability that x squared is less than or equal to some value little y. And again, little y here is just some sort of non-negative number. Okay, next, let's talk about this as the probability that negative, the root of y, is less than or equal to x is less than or equal to the root of y. Because this gives us something that we can integrate over, right? We know something about the probability density function for x, and so talking about probabilities in terms of x seems like a good idea. So this is the integral from negative root y to root y of 1/2 e to the negative absolute value x. Okay. Now we've got symmetry here and symmetry here. So this is twice the integral from 0 to root y of 1/2 e to the negative x. So this gets rid of that absolute value sign because we're dealing only now in positive numbers. The 2 and the 1/2 will cancel. So we've got the integral from 0 to root y of e to the negative x. And I probably should have been writing dx's here the whole time. Okay. And the integral here is negative e to the negative x. That's going to be evaluated from 0 to root y. So when we evaluate at root y, we get negative e to the negative root y. When we evaluate at 0, we get 1. So 1 minus e to the negative root y. And that's your cumulative distribution function for y.